All right, today we're going to be focusing on 3D figures and their volume. Our objective is that we will be able to use formulas for volume of three-dimensional objects to solve real-world problems. So, remember we talked about this in the last lesson. Volume is the space contained in the interior of a solid 3D figure. So think of things like fills or contains. Those are some key volume words. So in our pyramid, our volume is 1/3 B times H. The big B stands for the area of the base. And H is the height from the base to the point. In a cylinder, our volume is pi r squared. R is the radius. That's our symbol for pi. Remember on our calculators it's second and then the caret button. H still stands for height. And then for a prism, your volume is going to be the area of the base times the height. So let's start off with the first one, a rectangular pyramid. So we know we're using the pyramid formula, our 1/3 BH. That is 7 feet tall. So that's our height, and has a base that measures 5 feet by 3 feet. That's going to help us find the area of the base that we need to plug into our formula. How many cubic feet are contained, so that tells us volume, inside this pyramid. So before we can start with our volume formula, we need to find the area of the base. Since it's a rectangular pyramid, we know the base is length times width, which in this case is 5 times 3, which is 15. So now we can plug into our volume formula. Volume equals 1/3 times 15 times a height of 7. Put that in our calculator and we get that the volume is 35. We were measuring things in feet, and since volume is a three-dimensional item, we know it's cubed. Next, what is the volume of the following prism? Volume equals the area of the base times the height. Now, when you're looking at this, you might think that H is 16 because that's how tall the figure is. But the height of a prism is actually the distance between the two bases. So this is our height because that's how far it is between the bases. If we look back at this picture, base, here's our other base. The height is the distance between the bases. So we know that H is 10, but we need to find the area of the base, the triangle. And if you recall, the area of a triangle is 1/2 the length of the base times the length of the, times the height. So in this case, the area would be 1/2 times 12 times 16. So our area of our base is 96. So the volume would equal 96 times our height of 10. So the volume is 960. We're measuring with centimeters, and volume means it's cubed. Construction workers drill a hole into a concrete cylinder. Determine how many cubic feet of concrete are remaining. So since it says cubic feet, we know that we're working in a three-dimensional measurement here, which is going to be volume. So basically, here's where they're drilling the hole. We want to get rid of this, and this goes all the way through the inside of this. Here's our hole. That part is gone in the middle. Since this is 10 feet all the way across, we know that the radius would be 5 feet. It's 15 feet tall, and then there's 1 foot in between the hole and the edge. So technically what we need to do is we're going to have to find the volume of the whole cylinder. Then we're going to find the volume of the cylinder they took out, and then we'll subtract them to figure out what's left. So first, we're going to deal with the big cylinder. And remember, volume of a cylinder is pi r squared h. So volume equals pi. We said our radius is 5 squared times our height of 15. Now, to make things easier, I'm going to leave the pi in my answer for right now. And I'm just going to do 5 squared times 15, which comes out to 375. And then I'm going to bring down the pi. It'll make our subtraction easier later. So now let's find the volume of the small cylinder. And I just realized I spelled cylinder wrong over there. All right, so the volume of the smaller cylinder. We know that from the edge to the middle of the big cylinder is 5 feet. One of those feet is going to be left over, so we know that from the edge of the hole to the middle, that leaves 4 feet. So the radius of the small cylinder is 4 feet, and it's still 15 feet tall. So the volume equals pi times our radius of 4 squared times our height of 15. Again, we're not going to include the pi when we type this in our calculator. 4 squared is 16 times 15 gives us 240 pi. So our final volume would be 375 pi minus 240 pi equals 135 pi, which if we type that in our calculator is approximately 424.21 feet. And we're dealing with volume, so we know it's cubed, and also here it told us it was cubic feet. All right, so that had us taking a piece out of another. Now we're going to have two pieces put together. So if I could eat every bite of this dessert, how many cubic centimeters of ice cream and cone would I have eaten? So the top of this dessert is half of a sphere. It's one hemisphere of it. And then the bottom, the cone, is a cone. So we're going to have to find the volume of two things. We're going to have to find the volume of the cone, and we're going to have to find the volume of the ice cream. So the volume of the cone is 1/3 pi r squared h. So all the way across this is 8 centimeters, so we know our radius is halfway, and it would be 4. So the volume equals 1/3 pi times 4 squared times our height of 12. I'm going to again not include the pi when I'm calculating the volume initially. 1/3 times 4 squared times 12 would give us 64, and then we'll bring down the pi. For the ice cream cone, it's the volume of a sphere, but we only want half of it. So we want half of 4/3 pi r cubed Our radius was 4. Type everything but the pi in your calculator, and you would get 128 over 3 times pi. So the total volume would be 64 pi plus 128 over 3 pi. Type that all in the calculator, and we would get that the volume is approximately 335.1 centimeters cubed. How much of the ice cream cone is remaining after I've eaten 1/4 of it? So if we've eaten 1/4, that means there's 3/4 left. So let's find out what 3/4 of 335.1 is. That leaves us with 251.325 cubic centimeters. Your soccer ball holds approximately 360 cubic inches of air. So it holds, there's that much air inside of it. So it's telling us that this is the volume. What is the approximate radius of the soccer ball? So since we're dealing with a ball, that's a sphere. That's this right here. Our volume equals 4/3 pi r cubed. We know the volume's 360, and we want to solve for r. So to get rid of the 4/3, we would multiply by 3/4. The 3's cancel, the 4's cancel. 3/4 times 360 is 270 pi r cubed. We got to divide both sides by pi. We get 270 over pi is equal to r cubed. The opposite of cubing is cube root, which if you've forgotten on your calculator, it's math 4. So our radius, we're going to type cube root of 270 over pi into our calculator, and we get that the radius is approximately 4.41 inches. And I know it's inches because the volume was in cubic inches. All right, two small cylinders have heights in the ratio of 2 to 5. If you think back a couple units, that's our scale factor. So If the smaller cylinder has a radius of 6 centimeters and a height of 8 centimeters, what is the volume of the larger cylinder? So the first thing we need to do is find the volume of the small cylinder. And volume equals pi r squared h for a cylinder. So it would be pi times the radius squared times the height, which I'm going to leave the pi out again. And we get that the volume is 288 pi. So think back, we need to deal with scale factor to find our area ratio and our volume ratio. If our scale factor is 2 over 5, remember for our area ratio, we square each of those, so 4 over 25. And to get our volume ratio, we would cube these, so we would get 8 over 125. Now that we know the ratio of our volumes, we can solve for the volume of the larger cylinder. We know that 8 over 125 would have to equal 288 pi over x. We're going to cross multiply, so 8x would equal 125 times 288 would give us 32. So 326,000 pi. I'm sorry, that's wrong. That didn't look right. It's 36,000 pi. Then we'll divide both sides by 8. And we get that the volume of the larger cylinder is approximately 14,137.2 centimeters cubed. If the height of the smaller cylinder increases by a factor of 4 means we're multiplying by 4. By what factor does the volume increase? So volume is equal to pi r squared h. And we're saying that we're going to take our h and multiply it by 4. Now in math, you can multiply in any order. It's commutative. So this section right here is still our volume. So this would be our volume times 4. So we're just multiplying the volume by 4, which means the volume also increases by a factor of 4. What if the radius of the cylinder increases by a factor of 4? What does that do to the volume? Volume equals pi. We square r, so now we'd be squaring 4r times h. 4 squared would be 16, so we'd have pi times 16r squared h. Let's move the 16 to the end. Pi r squared h times 16. That's our volume formula. So the volume would increase by a factor of 16, because that's what we're multiplying by. Go ahead and write your summary, and I'll see you in class.